Hey guys, so this is a video I've been promising for quite a while. It's about the operation of the pressure assisted valve on RTI guns, in specific the Prophet 3. So I will conduct this video slightly different than I do most of them. You will get a close-up, but you will only see the things that I do and not my face. So I will just lower the camera so you can see the table. Okay, so over here I have everything laid out, so I will put this microphone slightly to the side and also the mouse, and let's get started. So I have here block that RTI kindly lended to me. So this block is with the cutout, so we can see inside of the action, which is really nice and really makes it easier to explain. We have the connecting high pressure hose between the body and the front of the gun. We have the spring for the hammer itself, the part which hooks the hammer and the pellet pusher, and it's connected with the rod on the cocking mechanism, on the cocking lever, the spring hammer adjuster, so spring hammer tension adjuster, and we have here the full valve assembly. So this is the valve housing, this is the valve itself and the spring, and this is the chamber which is necessary for this valve to work as a pressure assisted. And we have some O-rings. I will show where each of those go. And we have some nuts. These are for barrel, for tightening the barrel. And we have here the connecting rod for the trigger, which is not really important in this video, so we will put it aside. So I will just briefly show the layout on the block, on the action, or the body as they call it. So in here we have a hole where the valve housing is inserted. I will give more description about this later. And below that we have the one portion of the plenum, and it's connected through this hole in the bottom with the below the second part of the plenum. So plenum is there's two, let's say, cylinders, two holes for the plenum, and of course there has to be a hole in between, because those plenum work as one. They're just made with two holes in order to get the body vertical. And over here we have the slot for the barrel. The barrel inserts here, and over here on the top, this hole, or this hole from the front, is where actually the pellet pusher runs, cycles, and just below it is the hole for the hammer. And on this side we have cut out for where the pellet pusher locks, so the gun basically locks, gets in battery, if you will. And below there is a hole where you see the hammer in order for to cock it. This is actually new to the Prophet 3. And on the back side we have here space for the for this adjuster of the hammer spring. You can hear that there is a ball bearing, so you have clicks, and you have dents in this wheel in order to take advantage of this ball bearing. And here you have bleed valve, so basically here you can empty the gun just by unscrewing this, not fully, just slightly, so it starts to leak, and then this is how you drain the body. And that's about it in terms of what is the function of each part. The other side, which is not really focus of this video, but here is a trigger mechanism. So you see this long piece is the first sear that actually catches the hammer right here on this edge, on the top where my finger is. And the second is actually a sear that is connected with the trigger in the front, with the trigger itself. So this, I have to look, otherwise I will not hit it. So you put it like this together, and when you pull it forward, it moves and it unlatches the sear that is connected, that is pressed up against the hammer itself. The trigger mechanism is actually the same from Prophet 1, and it kind of makes sense because the trigger was always excellent on this gun. Not always actually, but all prophets, the priest at start didn't have really that good trigger. So let's get to to the differences that are being made to the Prophet 3 compared to the Prophet 2 and Prophet 1. Let's start perhaps with how the barrel is clamped. So basically you have on the top 3 holes now. You can see here 3 threads, and the front 2, so this one and this one, are actually used for fixating the barrel in place, and the rear one is actually just that there is a special kind of screw that has an O-ring on it, so it's just there, so it seals up the hole over the transfer port. They have to make a hole here because otherwise you wouldn't be able to they wouldn't be able to drill down the transfer port. So that's why this has to be closed off. But now this screw, which used to be for holding the barrel in place, is not used for that anymore. So you can always keep it in. It's just there to seal this hole so you don't get any air blow by around it. Okay, so one also very cool thing that is new only on the version 3 is that this part, which I mentioned before, which connects to the rod of the cocking mechanism, and it runs here like this, so it goes, let me try to show you this, it goes forth and back, and it has a function of cocking the hammer as well as pulling the pellet pusher back and forward, and also locking it in place when in battery. Now the difference is that there is a small screw here sticking out, so the head of the screw is sticking out, and this is because now this part itself is pulling the hammer back when you're cocking. So if we insert the hammer like this screw will interact with the hammer itself in this groove, and it will be responsible for cocking, for pulling it back. So the advantage this makes is that if you imagine the rod is here and the screw is right next to it. So before the force was, the rod was here and the force was here, so there is much bigger distance, and so you get kind of torsion force, which was not good, because before the actual pellet pusher was grabbing the hammer, pulling it back. Now this part is grabbing the hammer and pulling it back, and of course the force of pulling the hammer back is the largest force you have while you cock it. So this is in terms of hammer. Of course the hammer is now completely different. This is the groove you can see on top where this happens. So basically this part goes like this inside, and it catches on the hammer and pulls it back when you cock it. The hammer is full of holes now because it's much lighter now, because now we are talking about pressure assisted valves, so this is completely different, so it has to be much lighter. There is a detent here for the trigger mechanism. This, as mentioned before, this is where the sear is catching the hammer when it's cocked, and the other holes are there just to make the hammer lighter. And of course the spring is still inserted as always inside on the back side, and this is the hammer spring tensioner that goes, it also has a pin protruding, so it keeps the spring in the place. And in this part also has this nut on the top, and this rotates independently, meaning that when you have this inside, this nut, this screw actually, not nut, that is on the top, is in this hole. Basically it's not a hole, but yeah, it's a channel for the pellet pusher. So this means that when you rotate this to make adjustments, this part is actually standing still and only the other part is moving. And of course you can see it here that now it's moving out and here it's moving in. So actually on the production gun this will be a left thread, meaning that when you will rotate it right you will increase the power, so increase the hammer tension, and when you will rotate it left it will be reducing the power. But this one is still the prototype version, so it has a right thread, which is the wrong one for this application. Okay, so I think that we can move to the actual pressure assisted valve, which is the main portion of this video. So as I mentioned before, the trigger, the valve itself is composed of 3 components plus the spring. So the valve is one of them, and the valve is really special design. It has to be because it's pressure assisted. And the difference between the regular valve and this one is that there is actually a hole, very small hole in this stem here, right here by where the valve seals, and this hole goes inside, so inside and through into this empty space. So the valve in this side is hollow. And this hole has a very special dimension and very special purpose. Of course, if we were to put this kind of valve with the housing inside the gun without this chamber, which I mentioned on the start, then the gun would just leak through this small hole. It would leak slowly, relatively slowly, but it will still leak. So there has to be another part, and this is the chamber. And this goes over the valve like this. So the valve, this is stationary because you can see the threads here. This is stationary in the body and the valve moves like this. Okay, so this of course has a seal in the inside. It has an O-ring, so it seals around this let's call this piston and this cylinder. Okay, so on the valve there is a piston and here is a cylinder, and cylinder has a seal inside, so it seals it. And this chamber, so this hollow chamber is actually sealed towards the outside, so there is no so there is compressed air here if you do this, right? Or the only thing venting is this hole. So the whole idea of the pressure assisted valve is that when the valve is closed, so this part of the valve is pressed up against the ring inside here, which is really hard to see, and the position is like this. So let's put it how it is closed. From bottom side, so this is the side where the high pressure air will be fed from the plenum through this hole, this not circular hole. And we see here the back side of the valve, and on the other side this is the transfer port, and this is the front side of the valve. And when the valve opens, you can see here it will open and release the air through here directly towards the transfer port. And this hole inside from this side is actually not the same dimension all the way. Of course, it's first very big hole, so thin walls, and after that gets thicker, and that thicker part is where the valve sits and seals. And this thicker part starts right after this hole for air from the plenum. Okay, so it's kind of hard to see. Maybe you can see it like this if I shine correctly. I will try to zoom in for you afterwards. You will see the edge of where the hole is getting smaller. So in this case, the valve seals towards the outside. No air can go through this hole and out towards the transfer port, right? But the important thing is that the pressure, the force which keeps the valve closed is based on the surface area of the valve, or surface area of the smaller hole inside here, and the minus the surface area of this piston. because in here, in this cylinder, there is actually atmospheric pressure. So the only force that the valve is feeling is on this circle around it, and minus the piston, so it's not whole surface area. So that means that the valve, it's very easy to open because it has to overcome much smaller surface. And not only that, much smaller force because of the smaller surface area that is keeping the valve closed. And not only that, as soon as the valve opens, in that case, the closing force is still that very small portion, because you have to deduct the surface area of this piston, which is inside of this sealed chamber. But also on the other side, the pressure starts to get higher, right? You start to filling the barrel through the transfer port, so the pressure is higher on that side, and that surface area is actually much bigger because it's almost the full size of the valve. It's actually only minus this very thin stem, the 3mm stem. So actually, as soon as the valve opens, it actually continues to open on its own. The hammer doesn't even need to work so much. It just needs to start the opening process in order for the front side of the valve, so on the transfer port, to be pressurized. Once that is done, the valve will automatically open fully on its own. It doesn't need any more help. So that means that very small and short hit on the valve will open the valve always completely. And that is also the reason why the pressure-assisted valve, this pressure-assisted valve, cannot be used. You cannot use it. You cannot adjust the power just by simply regulating the force of the hammer. It will either open it or it will not open it at all. There is some small middle ground when you open it so little that there is not enough pressure on the front side that it would open on the transfer port side, that it would open it fully. But you want to avoid this because this is very this is not consistent. It will not do it always the same. So again, this valve is intended to be used that it opens always fully, and the only way to regulate power is by increasing or reducing the regulated pressure. And this is kind of the reason that why you have to use the enough force to open it always. And it doesn't really make a difference if you use too much force, because it will basically do the same thing. So it's only important that you use enough force. So this is why the instruction for using this valve is to have the hammer spring tension enough to open the valve at maximum pressure that you intend to use it, and then just change the pressure according to how much velocity, how much power you want, and leave the hammer spring tension as it is. So this is the main reason. Okay, so now we know that after the valve opens slightly, it will slam and open fully to the end. It will actually hit this cylinder side. It will open fully, really aggressively and really fast. And this is one of the key features why this valve is so good. So one is the fact that it opens really easy. So we need less force and less weight to open it, hammer weight. And the second one is the really fast opening once it starts to open. And then it will stay open actually because it wants to keep it open. The thing that it will eventually close it is the fact that we have that very small venting hole that actually vents the high pressure air on the transfer port side. It will vent it through this hole in the stem, throughout this piston into the cylinder. So the pressure in the cylinder is actually rising in the shot cycle where the valve is fully open. So, and once this pressure is rising, eventually it will tip over and the force for closing will be bigger than the force that is keeping it open. So based on that pressure behind, because it will have this the full surface area, it will not deduct the force that was created on this piston, because this will be pressurized by now. And of course, once this happen, and with an additional, with very small addition of also the force that the spring is creating, it will really rapidly close it. So if you think about it, how it operates, it opens really rapidly, it stays fully open for a while, and then it closes. So it's like this. So let's do it from our side. So it's closed, it's fully opened, and it stays opened, then it's really fast closed, instead of having this curve. Of course, this has much higher efficiency, pressure-wise, consumption-wise, everything is better in this regard. So this is the way the valve operates. And of course, after the valve closes, this chamber that is on the other side of the piston of the valve empties again through this small hole. And the volume here is extremely small, so there is no pressure loss. Let's say this area is of course then lost, but this is negligible compared to everything else. So still this valve has better efficiencies than conventional valve. So this is the operation, or hopefully I explained this well enough. So that's basically it. So if you look at, so we now look at the upsides of this valve. There's also slight downside. I mean, you can count as downside also that you cannot regulate the power via the hammer spring, but that is kind of unjustified, because you can regulate the power with the regulator. So who cares if you can regulate it with hammer spring? This is not important. There are some exceptions. If you want really low powers, it's really hard to get those low powers, so there has to be other restrictions to limit the power. And this is only relevant really for countries that have really limited maximum power, that is without FAC, of course, like UK or something like that, which is limited to 12 foot-pounds. This is just an example. But otherwise, there are mainly benefits. There is actually one more downside to this valve. You can call it downside, or you can call it upside also, and I will explain why. And actually this goes for most things. This valve will close faster if the slug is heavier, meaning that and the reason is really simple. If the slug is heavier, more pressure, and it builds faster, the pressure builds faster in the transfer port, simply because it is harder to move that slug through the barrel or pellet, doesn't matter. So it will close faster because this higher pressure will cause the air leaking through this small hole into the chamber to be higher. Pressure will result higher, faster filling speed, and faster filling speed means that it will reach the tipping point in where it will close sooner. Now, I said that this can be treated as a good or as a bad thing, but keep in mind that the good thing is that this valve actually regulates the power better. So even if you put a heavier slug, it will have roughly the same power. In other words, it will have really high efficiency, really high speeds with lighter slugs. So you can treat it as a good thing or as a bad thing. The bad side, of course, of that would be that if you put a really heavy slug, the valve might start to close so fast that it will actually reduce the power of what it could achieve. But the gun is really tuned nice, so it's really appropriate. The opening time, so the time that the valve is open, is really appropriate for the barrel length. So the RTI is taking care of that and adjusting. But I'm sure that some of you will try to modify this, and I'm not against it. Just beware about what you're doing. And here's a tip on how to make the valve open longer or shorter. If you want to have it open shorter, for a shorter amount of time, reduce the power, either increase the hole, the size of the hole, this very small hole, I believe is 0.8 millimeters, or reduce the volume of this chamber. So put something inside so the volume is smaller. That way the chamber will get filled faster and it will close sooner. And the same thing goes other way around. So if you want to have the valve open for longer, for high powers, reduce the hole size. This is kind of hard to do, of course, because the hole is already drilled, or increase the size of this cylinder. By the way, do not close this fully, because the valve will not close. So this hole is necessary. As mentioned before, the air has to go through this hole and fill up the chamber. Otherwise, the closing process doesn't start. So there is no. Don't do that. Okay, don't put a regular valve. Actually, you couldn't put a regular valve, but don't plug up this hole, because the valve will not close. It will just stay open. Yeah, let's just mention how this is all assembled in the gun, because this is something I really like. So as we mentioned a lot of times now, we have three components: valve, housing, and the chamber, or the cylinder, whatever I call it. I'm not sure. I think it's what I call it, the chamber. And these are three parts, and these three parts are all interchangeable. So unlike most guns, when you just can replace the valve, but the valve's housing or valve's bed is actually part of the gun body or the gun action, you can replace here everything. So in other guns, if you damage the body or where the valve seals on the body, you basically can throw this away, can throw the whole action away, because if that is damaged, you cannot repair it, right? It's integrated part of the action. But in this case, this is replaceable. The housing of the valve is replaceable. And the really cool part is how this is made. So of course there has to be O-rings here, because it's replaceable in order to seal. And you can see you have one O-ring here on the top. There is second O-ring here that actually comes on this place once it's inside. Of course it goes into this groove like this, in here, see it? Okay, let's put it to the light, yeah. There is also an optional O-ring which I would advise you not to put in. And this one is so this is the valve's housing, and this is the valve stem. You can put it on the stem, and it has a place inside. You see, it's right here inside. Hopefully, just a sec. Hopefully you can see it here by my finger. It's right here. The reason why I say that I don't really recommend it is because this O-ring can actually cause slightly lower consistency. Because of course when this is pressurized, the O-ring grabs to the stem a little bit, and it can cause slight deviation. It's not a big deal. Do as you like. RTI, I believe, doesn't put it inside anymore, simply because there is virtual no blowback. There's this tolerances between this hole in the valve housing, this 3mm hole, and the stem itself is really high, so there is virtual no blowback. Actually, a lot of manufacturers, for example, Edgun does this without any O-ring inside also. So, of course, this blowback would be only during the shot. It's not cannot cause any leaks. So, as I mentioned before, you place this inside, and you can see actually here quite an interesting thing. The valve stem actually protrudes very little out towards the hammer, and this is again because what we mentioned before, the hammer has to only slightly open the valve. After that, the valve cycle begins and it opens fully on its own. And also, if I just briefly assemble everything without the without the spring on the valve, so this is now everything assembled. And I will put the valve as forward as it goes, where it stops. And you can see now that actually it goes slightly more forward than as much as the hammer would push it. So the hammer hits the wall of the body before the valve ends its travel on the open side. And this is again for the same reason, because it doesn't need to push it fully open. The valve will fully open itself. It only needs to start pushing it. So this is just remark which is interesting, and just so you know that this is all done with intention. So the way you assemble this, of course, when you have the whole gun, not the cutout, you put the valve housing in. You pay attention that you have the hole for the transfer port on top. You can actually look through this hole down that you have it on top and rotate it slightly in order to do this. There is actually small milled portion here on the top where you have a set screw. This set screw pressures on that mill part, so it actually will align it rotationally itself when you do that. But don't over tighten this one, just gently tighten it, okay? So this is this set screw. And once this is inside, you can slightly tighten this set screw. Then you place your valve in. It's really hard to do this when showing you, so hopefully you can see it. Place your valve in, place your valve spring in, and then thread in, again, I will try to show it as good as possible. Thread in this portion fully, and again, don't over tighten it. Make sure it's tight so it holds, it's pressed up against. So I will show you now how it looks when it's there in the end. So it will be like this approximately, just a sec. Okay, like this, okay. Thread it fully in. There is a hex screw here, so you can screw it in. And once you are done with that, then you can proceed. Of course, you have to have O-rings inside and everything, so I'm just showing you now how it looks. Then you can thread the gun together, actually, because you usually thread in this side of the high pressure hose, connecting hose, to the front first. And once you tighten it on the front, then rotate everything and thread it together. And this one you don't tighten in. This one you align so it's correct distance front from the body. There is correct distance to be able to fit the side plates on. And after that you just pressurize it. So this one has an O-ring here, so it will seal here. And the air, when going from the regulator through this high pressure hose towards the plenum, will actually go around this part and into the plenum. Okay, so there is no seal between this part, the high pressure hose, and this chamber. There must not be, in order for this the regulator to be able to fill the plenum. One thing I forgot to mention before is also another thing they fixed on this P3 version is the really annoying squeak that most of RTI's guns had when the regulator was refilling the plenum. And that was, I mentioned this in a video before, that was because of the one-way valve that is on the front. And this valve is actually in this hose, so in the start of the hose where this is threaded in the front. And this is the annoying squeak, you would get after you take a shot, and then you hear that squeak, which is really annoying. You can actually hear it in a lot of my older videos. This is now solved. As you can see, there is an O-ring here, but below the O-ring, I will try to take it out now. So this is now an O-ring, which is NBR 90, so the hard one, and inside is actually a ball bearing. So this one, hopefully you can see it. So now this problem is solved finally, and this doesn't squeak anymore. So now there is no weird sounds when you, at least not in my gun. Hopefully you don't have any other experience on P3. So I think I covered everything. Hopefully I explained this well enough. Make sure you subscribe and hit the bell button so you don't miss out on any of the new videos. Thank you for watching, guys, and see you on the next one.